In this webinar, the PLANHEAT tool will be explained, how to install it, with the following approach and workflow. I'm going to also introduce what kind of data is needed to implement the PLANHEAT tool and what kind of workflow is necessary for a successful installation. Just one slide about the project itself. So this project is basically on mapping demand and provision of supply sources in order to plan new heating and cooling scenarios. And in order to do that, we will be able to simulate new scenarios and key performance evaluation. So what is actually the PLANHEAT tool? This is a QGIS tool or plugin based on an open source code which has the goal to analyze, plan, and simulate low-carbon heating and cooling scenarios. In every step of the process, the user is guided by module in a procedure that is starting from the assessment of the local heating and cooling demand and other potential sources that will conduct to the end user through the whole planning process, hopefully towards a simulation of future low-carbon scenarios. However, this is not only a heating and cooling and renewable energy source mapping tool, neither an optimization tool or a simulation-only tool. This is quite an integrated tool that is able to facilitate heating and cooling scenario creation, enabling their simulation. One should also note that according to the PLANHEAT city and district approach, this tool can be also used both for policy or master planning oriented activities, as well as for any kind of pre-feasibility study simulation of potential interventions in some specific city areas, which is coming from the district approach. The PLANHEAT tool is also a flexible and modular one that can be also used in a partial way, using single modules of the tool in order to provide the opportunity to the end users to apply the tool in quite different moments, importing or exporting various scenarios, or just loading partial results. In this way, also considering that some of the PLANHEAT approaches are very data demanding, or it can be expected to be data demanding, also time demanding in terms of scenario preparation, particularly in the case of district approach, still the end user can save at the end of each step the results of its work in order to keep on working and not to lose any kind of result up to that point. So it has a flexible approach which is adaptable to users in terms of data availability and scope, but also has a measurable approach which is defined by impacts, benefits, and savings quantified by KPIs in 4 different domains: energy, environmental, economic, and social. So as the tool is able to create different heating and cooling scenarios, all its modules and submodules cover all the aspects that are needed for a correct planning, enabling the user to study different scenarios that could promote heating and cooling decarbonization via demand reductions for example by the renovation of buildings, or the promotion of low-carbon sources, for example renovation of the heating and cooling generation stock. So this is the cycle of the process from planning to implementation with different steps. The end user can always choose between different approaches. The first one is the top-down or city approach, or a bottom-up district-oriented approach. Both of them can take the benefit from the results in terms of visualized maps and assess potential. So what is the differentiation between the two approaches? For the top-down approach, we have to have available data on energy consumption. It is provided maps at a city scale with an annual output. It can be considered relatively simple, and the outputs are useful for the identification of different interventions. While the bottom-up approach is more detailed about the information that a building is necessary. It provides maps at the district scale and heating and cooling demand curves per hour in the present or in future scenarios. It has an optimized hourly management strategy of the full heating and cooling feed or stock, and it has a more elaborate approach than the top-down version. Outputs of the bottom-up approach is useful for preliminary feasibility study evaluation. However, in both approaches it is true that they are capitalizing different PLANHEAT sources, the mapping module. In these, and also in the simulation module, they collect the info coming from the DMM and SMM through a 5-step procedure, which is going to be explained later on in this webinar. After that, the end user have the possibility to create new heating and cooling scenarios and also their simulation. As it can be seen, the source of the heat can come from different sources like solar thermal, biomass forests, biomass agriculture, deep geothermal, industrial excess heat, power plants, different data centers, supermarkets, water bodies, subway station, or even sewage pipes. So PLANHEAT tool uses a QGIS plugin. And actually this is also going to be described later on. In order to take advantage from all the PLANHEAT tool functionalities, it is recommended to use the tool in a web-connected personal computer or laptop or a mobile phone even. The PLANHEAT tool is needed as a desktop-based software, but some of the parts relies on web server data. Therefore, it is quite important to have a continuous web connection to the PLANHEAT web database. As the end user is able to work with the PLANHEAT tool via its single modules, as well as its via integrated structures, generating maps that are visualized via the QGIS environment, the numbers of different CSV files are transferred module by module towards the simulation of the whole scenario. So this is how the QGIS plugin is explained. as the user is able to work on single modules and then import or export previous works so that the information will be not lost in the middle. So how the user can work on the single modules with the PLANHEAT tool. The end user is able to evaluate current heating and cooling demands for a specific district, which is going to be drawn directly on the map, or for a groups of buildings that can be selected also directly from the map. The evaluation of the different demands of the buildings will enable the end user to assess heating and cooling demand of different building sectors, residentially or tertiary, different types of heating and cooling generation in terms of level of temperature, which can be low, medium, high, or DHW, different type of buildings via predefined categories in tertiary sectors like schools, hospitals, offices, or other municipality buildings, and also age, thus identifying on which buildings could be more strategic to act both at heating and cooling generation update and building envelope renovation. The end user is also able to evaluate future demand, proposing interventions at building level according to the type or singularity of a building and evaluating their effects on the demand. The user will also be able to see on the maps which are the areas where heating and cooling demand is the most critical. They will be also able to draw and study on the maps demand of new or future district heating and cooling scenarios. So an additional tool of PLANHEAT via the CMM is when the end user is able to visualize on the QGIS map demand values, as the tool is able, starting from an aggregate urban value of energy consumption, to disaggregate it on the map, showing in which areas heating and cooling demand is high. This can also enable the end user to evaluate per each single heating and cooling technology its level of penetration and of energy consumption in order to understand their weight on the general urban demand and propose renovation on a single heating and cooling technology or just on a single source. Similar approach and calculations are performed for the future scenario that the end user is guided to create in the city planning module approach. At the end of the city planning module approach, the end user is able to benchmark baseline and future scenarios and calculate also some specific KPIs at energy, economical, social, and environmental level that are common in both city and district approach. The user is also able to work on the SMM module thanks to the direct connection with existing EU country databases and atlases. Therefore, they are able to evaluate low carbon sources potential in its areas or cities and also see it on the map. Furthermore, this one is also able to assess the heating and cooling potential of punctual sources that the end users can identify on the map or locate it on the map, like industrial and urban waste heat sources. The DPM and the simulation mode collect the info coming from DMM and SMM, and it will guide through the 5-step procedures, again described in the next chapter, so that the end user can create new heating and scenarios for their simulation. So here is a picture when the installer is launched. And when the installer is launched, the user is prompted and asked to accept the PLANHEAT license agreement, which actually relies on the MIT license. So here you can see a screenshot about that. So as the user agrees the license agreement, she or he has the ability to select one of the QGIS compatible installation that is already presented on her or his computer in order to integrate the PLANHEAT tool into it. If there is no QGIS version is present at the user's computer, the user has the possibility to install a compatible version from the QGIS platform. So after the valid QGIS version is selected, the installation is started. In the picture you can see how the files are self-extracted in the process. However, it can also happen that the PLANHEAT button will not appear after the installation. In such cases, the plugin has to be activated manually, similarly to other QGIS plugins. In order to do so, the user has to go to the Plugins, Manage and Install Plugins section, and then manually check the PLANHEAT project bounding box. But in normal case, after the installation, the tool should be directly available in the QGIS interface as it is shown on the picture. Okay, so let's go with the focus on the bottom-up approach. In order to use the PLANHEAT tool via the bottom-up approach, the first step is to use the district mapping module. So the mapping phase is about calculating of the demand and the sources potential for evaluation. It starts with the baseline scenario about characterization and assessment, continues with the planning criteria selection for future scenarios, and check and comparison. So the district mapping module, which can be found actually in previous training modules of PLANHEAT, as all PLANHEAT tools, is a simple or easy interactive and user-friendly interface that guides the end users in the upload and provision of all necessary data for the DMM that are related to shapefile or general information. This one is also able to calculate the current or future demand of buildings or districts via two approaches. One is the simplified one, which requires very few data to be inserted by the end user, and the complete version, whose demand calculation is as more precise as more data per building can be provided. It's obvious to state that in case of absence of some data, which let's assume all the time can happen, the PLANHEAT web server database includes some information or EU statistical data that can be used by the end user at this purpose. In this case, the end user can reach them connecting via web to the PLANHEAT database. Mandatory data for using the DMM are the type of building, the centroid, the surface of the building, and its height. Each building which is part of the analysis is then classified with an ID that also facilitates the next steps. So here you can see the picture of the next steps. And as said, other data like age, use, facade area can facilitate a more accurate evaluation of heating and cooling or other demand. So in the end, it is going to be a shapefile of the district or the actual area that we are investigating. And here you can see the most frequently used parameters that are needed. Like again, the identification code of a building, height, the number of floors, the year of construction, and the purpose of the building. So the bottom approach, as mentioned, has these two kind of different version, the complete and the simplified. And the user is able to decide which one to use. There are additional parameters for the complete version. So not just building ID, age, use, but also roof area, facade area, the volume of the building, and the protection degree is visualized in here. Of course, for the simplified version, less parameters are adequate for the analysis. So as the DMM appears in the QGIS environment via visualization, which can be seen on the left, the user is able to interact with the building shapefile, which is properly uploaded by the user. In this way, the end user is able to state which type of demand, heating, cooling, district heat water, residential, tertiary, low, medium, or high temperature, he is interested in to assess, so that he or she is going to be able to visualize it on the map. So basically, this is how to interact with the DMM in the PLANHEAT QGIS environment. In order to go on with the process, the user defines the generic data of the project. He or she selects the name, area name, and the country, uploads the shapefile with the case study information, defines the output files folder, and if it is necessary, uploads the leader file and selects the assessment methods. Again, in the picture, we can see that the user is able to define which version to follow from the drop-down menu, where the method of simplified or complete procedure can be selected. With all PLANHEAT modules, the end user is guided to the provision of the required data, information, or file to run the district mapping, both for current and future demand. Future demand calculation can be implemented or required both a single building, which is selected one by one on the map or the building list, and to be provided per each of them related to the info to the renovation. So this is some screenshot about the future refurbishment scenarios as regards of the bottom-up mapping. So it takes into consideration heritage of the building, what the building is used for, its age, refurbishment level, and the refurbishment element as well. So here are when the matching of the results are processed. Again, a screenshot about that. And this assessment recap is actually based on CSV files that the tool is able to generate for both current and future demand, and that are then passed and used in the different modules for the simulation of local scenarios. Here you can see an example from the Antwerp case. When all the required data are provided, the DMM can start its processing to calculate and draw maps that can be easily read via colors, so that the end user is able also to put one layer on the other and also to choose color legend per each map to facilitate the readability of the maps. Here we can see an actual example again about Antwerp, where the different colors represent different layers for the different scenarios. So this is one example of results of the building level shapefile utilization for the DMM visualization. So as it was mentioned, the DMM can make a complete assessment of heating and cooling demand per type of building, age of building, type of service that the building is meant for, level of temperature, in order to enable the end user to understand which type of district buildings are more or less energy demanding. The results coming from the DMM or SMM will be then used and transferred to the DPM. Here it is going to be described step by step. This is how the district planning module or DPM workflow will look like. So first of all relevant information from the mapping module are imported and visualized, so that the baseline scenario can be characterized according to the residential, tertiary, or transport sector. Then the scenario will be assessed based on an hourly basis simulation, and KPIs will be computed from them. The KPIs and the planning criteria will be selected with energy sources prioritization, and future scenario characterizations in order, and the optimization of DHC networks will be accomplished. So these are the steps for the planning simulation module, which is able to work on the sources or technologies or benchmarks for current and future scenarios. The district planning module is also able to generate several types of heating and cooling scenarios, starting from local assessment of demand and sources. So again, here the user is able to create a new project or just simply import a previously saved project from the integrated tool page. She or he can select the item of planning and simulation module, and just clicking on the start button, the district planning module starts. However, it should be noted that to start the module, it is necessary to have been previously run DMM both for the baseline and future scenarios. So after that, when the tool is running for the first time, the district planning module button is the only possible choice. Such infos are transferred to the DPM directly from the DMM. However, it is relevant to say that the end user is able to create new scenario based on a previously saved mapping assessment or from a unique workflow, as it was already referred to. The DPM is a step-by-step process, and altogether 5 steps are foreseen. Step 0 is the only possible choice at the first time it is run. The other buttons are still grayed out at this point. So step 0 is actually from an import tab where the maps and data coming from the DMM and the SMM are directly transferred, and they can be uploaded in case of a subsequent use. Inputs and maps can be charged directly via uploading them as well as drawing them on the QGIS environment. In this way, the end user is also able to identify or design on a larger map a specific area which will become the area of analysis of the DPM, and automatically all the info related to a demand or sources potential on that area are transferred, and the maps become visible in the QGIS visualization layer. It's relevant also to note that the end user has to keep its personal computer or laptop continuously connected to the web in order to facilitate the download of OpenStreetMaps layer, which is functional to all DPM and DMM analysis. So here you can see a screenshot where it is imported from the DMM. Again, another screenshot showing that the attribute table provides a summary of attributes of all building comprises in both baseline and future scenarios. So here is when the import from the SMM is given, and the district tab provides the information about the local sources that are available in and around surrounding the group of buildings. It should be noted that in order to calculate this information, a dedicated shapefile has to be created, which can be created now or loaded later on. Also, similarly to the shapefile, it has to be retreated to download the street routes by clicking on a dedicated button, and only after downloading the streets would be possible to proceed with the next step by clicking on the dedicated next button. So here you can see the transition from step 0 to step 1, where some of the maps are already loaded. And now it is going to be possible to extract step 1, the baseline scenario definition. Let's see how it is done. So step 1 is dedicated, as mentioned, to the characterization of an existing baseline scenario and is able to charge local GIS map and find all the info related to the demand of the buildings coming from the mapping module. Knowing the local situation, the end user is able to define which technologies and sources are used to cover this demand. By selecting each of the two options, the respective tabs related to the scenario's characterization and technology assignment will be enabled. So step 1 for network approach, a subtab of networks tab will help to make it possible to create a district heating network from actually zero. By clicking on the Add Network button, it will be also possible to give a name to a new network. Then the user has to select from the list to create created networks, which is going to be possible to edit later on by pushing the correspondent button. So the single building approach are presented, and the shape files per each of them, the user has to define heating, cooling, and district hot water technology. Buildings can be selected on the list or from the map, and clicking on the values from DMM that are imported in terms of peak power for sizing of the generators. In the next tab, which is called Supply Energy Sources, all the given fields have to be edited manually. And in the Transport Sector tab, all the fields also have to be edited manually. And by clicking on the button of Confirm Baseline Assessment, the step 1 procedure will end. It also should be noted that the user can choose buildings, sources, and technologies to be allocated. So the user is also able to select an area of the district and provide information about the heating and cooling technologies and also sources for that area. So let's see about step 2. Step 2 is dedicated to the calculation of the key performance indicators of the baseline scenario for all 4 important domains, again, energetic, environmental, economic, and social, and all the KPIs are related to the baseline scenario, calculated and reported by clicking on the dedicated button. By clicking on the OK button on the right bottom corner of the window, the step 2 ends and the step 3 is enabled. It should be noted that when the step 2 button is enabled and the user is able to launch the simulation module and also to perform a 1-year simulation on an hourly basis of the local scenario calculating relevant KPIs. So let's see step 3. In this step, the end user can identify the planning criteria that will guide its planning activity and also to assign a weight factor to it and then to set up which KPIs to be viewed after the simulation and to define targets per each of them. According to the selected planning criteria, energy sources are prioritized in Sources tab. Values or prioritization are expressed via percentages in order to present how much the sources are valuable according to local assessment and weight. Weight can be assigned to each of them to take into account the priority among criteria that can be in contrast, and up to 3 energetic and environmental criteria can be selected. Also, it should be noted that up to 1 economic criterion can be selected. So according to the planning criteria which was previously selected, the source optimization and prioritization algorithms provide a rank of sources which allowed the end user to select properly the technologies in the future scenarios creation process. In this visualization tab, the KPIs guiding the creation of future scenarios can be selected, and targets can be assigned to each of them to take into account the priority among criteria that again can be in contrast. It is important to note that the suitable number of KPIs should be identified. For example, 1 out of 4 to be selected for energy, and environmental, at least 1 out of 3 should be prepared. In the Visualization KPIs and Target Values tab, according to the planning criteria selected, it is possible to set target value for the KPIs, calculating the performance of future scenarios. In the table are also reported the baseline scenario KPIs, which were previously calculated as a reference value to set the targets. Once these targets are set, it is possible to advance to the next step of the DPM workflow by pushing the OK button. It also needs to be noted that in every moment the user has the possibility to come back to the previous steps to make or alter any changes. So let's see the next step, step 4, which is dedicated to the definition of future scenario, and it follows an approach identical to the baseline scenario creation. Well, starting from the baseline scenario created in step 1, the end user is now able to change sources and technologies building by building or at a group of buildings. Buildings can be selected directly on the map or according to their identification number, which is coming from the DMM, or also by the type of buildings, in case the end user would like to implement a specific technology per each building. At this stage, the end user is also able to optimize the routing of new or existing DHCN via the DHC Route Optimizer. The objective of the optimizer is to provide an optimized district heating network pipe design in terms of diameter and routing and also length, and to identify the new consumer buildings to connect during the future scenario creation, and also the associated cost of the network development, starting from information related to local demand and available generation points according to their location. The DHC route optimizer has several applications depending on the data and the expertise of the end user. The DHN of the future scenario has been added in the layers tree on the left side on the picture of the main QGIS dialog window. Following the PLANHEAT general approach that gives the possibility to both skilled and less skilled users, it is possible to use the tool even in case of the lackness of data. When the network of the future scenario is created, in the Network Characterization subtab, it is possible to assign the technology to the characterized generation point. And it is also possible to take into account the already existing technology as it is imported from the first step, or by modifying it, for instance, by increasing its capacity or efficiency with the same procedure as was done in step 1. Also in step 4, in the Supply Energy Sources tab, the information input in step 1 are imported. The fields can be edited by the user in case the values are very different from the baseline to future scenario. In the Fields of Transport Sector tab can be edited according to the target set for AN10 KPI. On the right corner button of its tab, it is also possible to confirm the future scenario assessment and move to the district simulation module. At the end of step 4, the end user is also able to redefine, if needed, the sources and transport tabs of the baseline scenario before starting the final simulation and benchmarking between baseline and future scenario. The District Simulation Module, or DSM, button is now active. By pushing this button, the engine for the optimization of the operational cost and the calculation of the key performance indicators is running. Once the simulation is performed, the results are shown for the KPI selected back in step 2, and the target values are going to be verified. Again, KPIs can be seen for each domains. The final energy consumption and the primary energy consumption of the scenario are also calculated, as shown it on the picture. So continuing with the DSM process, by pushing the simulation button, the engine for the optimization again is run. In the Local Source Availability tab, the final energy consumption for the local sources utilized as the result of the simulation engine and is compared to the amount of megawatt hour per year of the same sources available as calculated by SMM. In case the verification fails, a warning message already coming from step 3 is displayed. Another future scenario with new parameters has to be set up. If no renewable energy sources are mapped, then the tabs present 0 or none. In the last two tabs of DSM, data visualization for district solution, and data visualization for individual solutions are shown, and the hourly profiles of technology utilization for each district and each building in the future scenario can be visualized, as it can be seen in the picture. That was more or less about the current status of Module 4 in PLANHEAT, and I would like to suggest and to recommend to follow up our project, which is going to be over in a few months. So basically, I would like to recommend you to visit our project website, our e-learning platform, where all the webinars recorded and will be uploaded, along with all training materials from all modules available will be uploaded. The different courses and documents are available. The forum is operational, and we have a frequently asked question section of the website as well. We have the Ask the Tutor feature also represented on our website. If you would like to use our tool or have a trial about it, again, please check out our website and let us know if you would like to have a test with that. Of course, more information about how to use the tool is continuously updated and uploaded to the e-learning platform as well as this guidebook, which is actually the presentation of today, will be also presented there. So I would like to thank you very much for your attention, and I hope I could give a decent overview of the fourth module of PLANHEAT. You can also check out our social media channels, and if you have a very specific question, please do not hesitate to write us an email as well for info@planheat.eu. So thank you very much for your attention.